Greetings, mathematicians. Today we're looking at example 3, creating equivalent rational expressions for 3a and 3b. And basically, this would be a step that we would take when just before adding and subtracting fractions to get a common denominator. So our original denominator is original fraction 7 over 5p squared, and we want to write the equivalent fraction where 20p to the 6 is in the denominator. So that means I'm going to write our first fraction, 7 over 5p squared. I need to multiply that by a ratio that is going to give me in the denominator 20p to the 6. So the focus on the denominator. 5p squared times what gives us 20p to the 6? Well, 5 times 4 gives us 20. That one's nice. P to the second times p to the fourth is going to give us p to the 6. So together, 5p squared times 4p to the fourth gives us 20p to the 6. If I multiply the denominator by 4p to the fourth, then I have to multiply the numerator by 4p to the fourth. Because what I'm really doing is multiplying by 1. I'm multiplying by a ratio that will give me an equivalent fraction. So now that I have the denominator set, in the numerator it's 7 times 4p to the fourth. And this is the answer that we need to write over here in the numerator from the original example. So 7 times 4 is 28, so 28 goes there, and it would just be 28p to the fourth. Now, when we're writing the equivalent fraction, we don't want to simplify it, because this is what we want to use when we're following the next step in the process of adding or subtracting fractions. If we did simplify it, we'd be getting back to this fraction over here, and we don't want that here. And we'll look at that further in example 4.